Getting them out has been sort of a bit tricky. Come on. Hello and welcome back. This is something I found on eBay. It makes little cylinders of ice. Now this one fits quite nicely in there. This will contain my sodium nitrite solution. This, however, is the largest and won't hold on to my cup. It will, however, hold on to this, but I think it's too small. I need to keep the reaction below 5 degrees. Just wait 20 minutes, see if I can get this to sit inside. Tip: cover these with aluminium foil, because this happened when I tried to make sulfuric acid the other day. First, we want 13.5 grams of aniline. We have our aniline from the other day. We have 13.6. There we go, 13 point. That'll do. I call this 3.5 milliliters, 15% hydrochloric acid. We have a beaker with stirring. No heat is applied at this time. We add our 13.5 grams of aniline. Make sure to get every last drop. Now we slowly add the hydrochloric acid. This will form aniline chloride. As you can see, it forms and redissolves. This is an exothermic reaction. The product forms and redissolves. Moderately warm, but not too much. I got that last step wrong. The amount of hydrochloric acid needed is more like 30 to 40 milliliters. So I'm simply going to add another 30 milliliters. You can see the aniline chloride, which will hopefully redissolve. Quite a lot of solid still in there. Okay, this is not dissolved, so what I'm going to do is add some cold water to help the aniline chloride get into solution. We're actually still trying to dissolve this stuff. Notice how it floats. To prepare for the next step, we take 10 grams of sodium nitrite, which is NaNO2, as opposed to sodium nitrate, which is NaNO3. So we want 10 grams of this. Put this as precise as I can. You don't want to handle this because it is poisonous. Here is our 10 grams sodium nitrite. This is highly soluble in water, and we've taken 25 milliliters of water. This is endothermic, so the beaker is going to be nice and cold. In here we have our 10 grams of sodium nitrite. Now then, this is still not dissolved properly. But it's getting closer. I might transfer it into a slightly larger beaker here and add as little water as possible to get it to dissolve. So my aniline chloride almost dissolved. This is rather a murky solution. I'm starting to regret not purifying my aniline, but we shall proceed. Here I am creating an ice bath. This is getting closer to all being dissolved, and I've added this. I should be able to carefully add my sodium nitrite to this dropping funnel. The next step is going to be drop-wise introduce the sodium nitrite to our aniline chloride, producing a diazonium salt. Diazonium salt is unstable and it needs to be performed below 5 degrees Celsius. The thermometer probe has been added to the reaction mixture just to gauge the temperature. We have 6 degrees, so it's in fact a little bit hot still. It's not uncommon just to add an ice cube to the reaction mixture. This should ensure that we have low temperatures. We are within range. The metal probe being metal, it can interfere with the stir bar, but I've got it to be spinning and reading the temperature, which is 3 degrees, 2 degrees. I'm going to start drop-wise adding our nitrite. Gentle drop-wise addition. Here we go. Ooh, possibly too fast, but it is dropping in. Our reaction will be proceeding. There's a good gauge of how fast it's dropping. I like this funnel. Ooh, we have gone back up to 4 degrees. How about we just stop it for a second? Excellent. And we'll start it up again. Until we see 4. Four degrees. Stop this. 5 degrees right here. Come on, ice. 6 degrees, that's not good. So we want it to cool down as quick as possible. This really must be done slowly. Here we are continuing. I'm not sure if it's me, but I think this is turning red very slowly. Something unexpected has happened. Beneath this surface there is a very yellow looking solution. The addition is not complete. It's 4 degrees, we've not gone over the 5, but something is a bit amiss because we shouldn't have all this precipitate. I think we've formed some kind of azo dye by mistake. Certainly quite a lot of solid product in there. aniline, I'm going to redistill so that we have a chance of doing this successfully if this doesn't work. Yes, there is stirring underneath. There really is a lot of solid in there. I'm going to leave this stirring and let it come to room temperature. So, it's times like this you want a teacher so you can go, "So, what's happened? Why is this not working?" Anyway, in the oven I've got some glassware ready to do a distillation when I've finished dinner. Interesting. Here I'm set up to redistill my remaining bit of aniline. You can hear some bubbling. That's nitrogen being released. I've removed a lot of that solid gunk, and this I'm going to warm up slightly. Finally, we have what looks like a clear liquid. To the crude, which I was working with before. That explains all this gunk, I think, I hope. Can you hear that nitrogen? Still not very warm. It's a little bit warm now. Yeah, but we want it to be like 50 degrees, but no more. Here we seem to have collected most of our aniline. It looks good. Leave it to go for a few more minutes. I added the solid stuff, or the precipitate, and it seems to be slowly turning into this tar, which is not a bad thing, because then I can just pour the liquid off it. So I'll keep warming this up. Here we now have 10.8 grams of aniline with a bit of water. Oh yes, look at that. It's just doing this on its own. Sitting there for some time, just bubbling away. Round 2.
Round 2.
We'll add some aniline to our hydrochloric acid.
Fight.
Aniline chloride, which will dissolve. Very nice. Easily done. It's nice and warm. We'll cool that down in ice water. And in here we'll make up another nitrite solution. This time we're preparing 8 grams of sodium nitrite. It appears my aniline hydrochloride has precipitated out. That's not what we want. Possibly some water is needed. Oh, that tar was horrendous. Couldn't get it off my fingers. It's still bubbling a bit. That should dissolve it. Yes, it has dissolved. Aniline hydrochloride, and it's a clear solution. Aniline hydrochloride stirring in an ice bath. Here's my 8 grams of sodium nitrite. ready to add to my cold aniline chloride in hydrochloric acid. The nitrite reacts with the hydrochloric acid to create nitrous acid. Our solution is clear. I feel more confident about this one. Still going. A little way to go. Temperature within range. The last few drops. We have a slight colour change, but it's looking good. 4 degrees. This is perfect. There's no floaters worth speaking of. Here we go. All has been added. In here we have our benzene diazonium chloride. This could in fact be reacted with aniline, with phenol, with beta-naphthalene, making different azo dyes. But in this case we are hydrolyzing it to phenol. It's slowly coming to room temperature and we can see bubbles already. And you can hear it. This time it's going to plan. Bubbles, bubbles of nitrogen. If I turn the stirring off, do we see any bubbles? Yes, we can see bubbles in there. Yeah, you can see it. So you can see nitrogen forming and escaping. This is our hydrolysis. This is the diazonium salt decomposing, giving off its nitrogen. We can now warm the solution. It is currently 18 degrees and we want it to reach about 50 degrees. I think that should do it. Tiny bit of stirring. Oh, actually no. Helps if you put the thermometer in. Yes. So, I'll be back when this is warmer. 26 degrees. And it is certainly releasing its nitrogen. This is proceeding nicely. It's 32 degrees. We are seeing the smallest hints of some tar forming. But as long as it's minimal, that'll be fine. So I'm putting it in some cold water to cool it down. It was bubbling a little bit too much. We're still going with the hydrolysis, probably another hour to go. It is dark in colour, and there are a few floaters, but we are certainly doing better than we did last time. Oily tar. Yes. Although this could be phenol. It's really only at the surface. Quite pretty looking though. Yeah. With the right angle. Oh, look at that. Just as a reference. So to try and extract the phenol, I'm going to use this bit of ethyl acetate. It appears to have taken all that tarry stuff as well. The separatory funnel has a small amount of chloroform inside, and I believe a mixed solvent will in fact help in the dissolving of the phenol. And here it is. This is our organic phase.